Okay, we're ready to show this modulation amplifier. The first thing when you get this is to remove the packing materials inside. Just over the fan there's a little piece of foam, and just take that out so the fan is free. We're going to leave the lid off because we're going to put tuning capacitors in there. Power supply for this is just this small plug-in. This has the US plug on here. You pinch this together to release it, and then put your kind of plug in there. I think this is the European, probably the one in use in Italy. Just put this in there, click it in, click it out. Today we'll use the US plug. On the back of the unit, there's some connections, one of which is the power. It plugs in there. The reference from the lock-in plugs in here. Lock-in monitor output, so you can monitor what's going in from the lock-in monitor on the output. And the other connections on the back are for the modulation coils. I'll plug that in. The other end of the cable is the old Varian style. Today we're going to use these old Varian modulation coils for our demonstration. We use a Bruker modulation system. Plug this adapting cable into here, and this into the Bruker. We need to select resonating capacitors for the frequency that we want to use. The first thing that needs to be done is you need to determine the inductance of the coils. Inductance is going to be 1 over omega squared C. That's the same as 1 over 2 pi frequency squared times capacitor. We just have to select a capacitor and see what inductance that results in. There are 2 frequency selections with this switch on the front panel. There are 2 sets of capacitors, one for position 1 and one for position 2, and each of those sets is 2 capacitors in parallel. So there are no capacitors in here. Now we're going to put in a capacitor as a trial to find the inductance of the coils. This is 0.68 microfarads, and we'll plug that into the connector that is for frequency 1. Turn this on. Then I'm going to monitor the signal coming out of the signal generator. This is just a simulation of your lock-in amplifier. So this is the lock-in output going to the lock-in input. The level that we want to set there will be 1 volt peak to peak. This is not real critical, but everything's sort of calibrated to that. Now we're going to monitor the current flowing in the modulation coils from this port. This is a voltage that's proportional to the current at 1 volt per amp. So we're going to put that on channel 2. Now we're going to look for the resonance. And there it is. You see the current responds by coming to a maximum at the resonant frequency, and also notice that it comes into phase with the driving function. So 2 things happen at resonance. One is you get the maximum current in the coils, and the other is that you're phased correctly with the locking. Now, you notice that it's an anti-phase. It's it's 180 degrees out of phase. There's a switch on the back of the box. So now it's in phase. So that way you can plug all these cables together without worrying about phase. And when you get your first spectrum out of it, you can tell if it's upside down or not from what you want. We've now found that for this particular coil and this particular capacitor, we have a resonant frequency at 14 kilohertz. Now, using that equation up there, we can calculate that for our situation today, this is 181 I got micro henries. This is kind of an intermediate frequency here at 14 kilohertz. We can go down to a very low frequency. I'll put in the biggest capacitor I have for the frequency number 2, 1 microfarad. This goes over on the other side. We can calculate the frequency. Frequency in hertz is 1 over square root LC times 2 pi. 11.9 kilohertz. Tune it into that. Looks like it's about there. And that came out pretty close, 11.4 kilohertz. I believe you wanted to get down below 10 kilohertz. So we can put another capacitor in parallel with that 1 microfarad. Now we have 2 capacitors in parallel, 1 microfarad and 0.68 microfarads. We'll look again for the resonance. It's down here at 8.6 kilohertz. I want to talk a little bit about amplitude. I'm going to turn the current monitor to 0.5 volt per division. This is modulation amplitude. The amplitude will become quite large down at this low frequency because the amplifier doesn't have to work very hard. You ask for 1.5 amps peak to peak, and you can see that's very easy to do here at this low frequency. We will put in a very small capacitor, 0.01 microfarad. I'll put that in the number 1 frequency spot. That is going to take us up to probably a little over 100 kilohertz to a higher frequency. Let's see if we can find the resonance there. Yeah, there it is. Okay. I have to turn the amplitude up a bit more now at the high frequency to get the higher voltage across the inductor. We're still at a 0.5 amp per division, so there's 1 amp peak to peak. This frequency, by the way, is 116 kilohertz. We wanted to get to at least 100. Those pins that accept the capacitors also fit just the leads of regular axial lead capacitors, so we can